Very good morning, students. My name is Ranveer Singh. I am your physics teacher. Let's come to the topic. Today we will discuss what is thermodynamics. In thermodynamics, firstly we want to know that what is a thermodynamic system. In general language, what is a system? A system is a device or arrangement which can do any work. For example, by this marker we can write over here. So this is a system. Computer is also known as system because computer can do calculation, data storage. So what is thermodynamic system? In terms of thermodynamic system. Firstly, first heading is thermodynamic system. Thermodynamic system is a system which can be expressed in terms of pressure, volume and temperature. Or in simple language, if you see three things, pressure, volume and temperature in a device or in arrangement, then that system is called thermodynamic system. So it can be expressed in terms of pressure, volume and temperature. For example, there is a gas filled in a cylinder contains a movable piston which can move upward or downward according to the situation. In this system, there is a gas have some pressure. We are seeing that the volume of container is the volume of gas, so there is volume, and the surrounding where this piston is placed, cylinder is placed, the temperature of surrounding after some time equal to the temperature of gas is equal to the temperature of surrounding after some time, because after equilibrium established, the temperature of surrounding and gas will be same, so there is a temperature. For example, in our kitchen there is a device known as cooking cylinder. Cooking cylinder, there is some gas. It means say gas has pressure. Volume of cylinder is the volume of gas, and the volume temperature of kitchen room is the temperature of cylinder. So in cooking cylinder there are three things available: pressure, volume and temperature. So cooking cylinder is the best example of thermodynamic system. And now we are discussing the types of thermodynamic system. This is the thermodynamic system contain a movable piston which can move upward or downward. If we start giving heat to this gas, the temperature of gas will be increased, and piston can be moved upward or forward, upward or downward. Here, here heat exchange, but piston is fixed, locked. There is no leakage, so heat can be exchanged, but matter does not. Exchanged, but matter does not. Matter does not. This is closed system. This is closed system. Now, second example. This is a cylinder having some gas, and cylinder is completely surrounded by a perfect insulator. So if the temperature of gas is less than from surrounding, heat cannot be enter into the system, and if the temperature of surrounding is less than the temperature of gas, heat cannot be comes out from the cylinder. So there is no exchange of heat. No exchange of heat. No exchange of heat. And no exchange of matter because system is closed. No exchange of matter. So this is open system. Sorry, this is closed system. Close. This is isolated, and there is another system. For example, there is a cylinder having some liquid or gas. Cylinder is open. If we give heat to this system, liquid, if there is liquid, liquid can be vaporized, and in form of vapor it go from gas to liquid to outside. So here heat is also exchanged and matter is also exchanged from system to surrounding. This is open system. Open system, heat and matter both can be exchanged. Both can be exchanged. So this is a explanation of system, what is a system, and now we will discuss work done by thermodynamic system. Work done by thermodynamic system. Let there is a cylinder having a piston. Piston can be moved upward or downward. The cross-sectional area of piston is capital A, and this is a gas having some volume and some pressure. For example, initial volume is Vi. Initially, its volume Vi. Now energy is given to the gas, or we know that the molecule of gas moves randomly, and due to this motion they strike with other molecules and the wall of vessel. So the molecules of gas strikes continuously at the bottom of piston. They strike on the piston, so they exert a force on piston. So force on piston, force is pressure into area. So this is the force exerted by the gas on the piston. Due to this force, piston moves some distance in upward direction. This is delta x. Then work is force into displacement. It means PA delta x. Here A cross sectional area, delta x distance. Area into distance is volume. We know that area into distance is volume. So area and distance, volume of this part. So A into delta x is volume of this part, and the volume of this part is also written as this volume minus this volume. Volume of this part this part, suppose that let's say this part volume delta V, then A delta x is written as delta V, and delta V is also written as V final minus V initial. V final minus V initial, then formula of work is written as V final minus V initial, or we can say that P into change in volume. There are two different cases in this formula. If work is done by system, if work is done by system or gas, because here system is gas and the tendency of gas is to expand. We know that tendency of gas to be expand. So if work is done by the gas is trying to expand, it means final volume will be greater than initial volume, final volume greater than initial volume. This quantity is greater than to this, so W will be positive. So you have to remember that if work is done by the system, work done will be positive. Work is done by the system positive, by the system positive, or V final greater than V initial. If work is on the gas, for example, this is cylinder on the gas, means we are trying to push down, the piston. So push down the piston, piston reach here. This is initial volume and this is final volume. Here V final less than V initial. If V final less than V initial, V final is less, so there is negative, so W will be negative. So on by the system positive, on the system negative. Okay? Sorry. Next, now indicator diagram. Indicator diagram is the graph between pressure and volume for a thermodynamic system, which represent the different state of thermodynamic system. Here I am taking one example. Let this is a gas having some volume and having some pressure. At this axis we are taking volume and at this axis we are taking pressure. Suppose that there is some initial pressure and volume. For this initial volume and initial pressure, that point will be here. And you have to know that one thing, if temperature increases, pressure of gas increases. Temperature if increases, then volume of gas, temperature increase, pressure increase. Best example, in pressure cooker we know that when pressure cooker kept on the burner, on increasing temperature, pressure inside pressure cooker increases. On increasing temperature, pressure increases. On decreasing temperature, pressure decreases. And if pressure decreases, piston is trying to expand or gas is trying to expand. Now we are giving some heat to the gas. If we are giving some heat to the gas, just a minute. Pressure increases, gas is trying to push piston upward, piston will move here. So if you are giving heat, pressure increases and volume also increases. So next point, volume increases, pressure increases. Point will be taken here. Now again giving heat, pressure also again increases, volume all increases, pressure increases, volume increases. Third point will be taken here. So this is graph. This is state 1 and this is state 2. In graph we will write here state 1 and state 2, and piston is taken from 1 to 2. So arrow will be indicate this graph. And in other example, suppose that there is a piston containing gas. We are taking volume, pressure. Initially suppose that this pressure and this volume and pressure is this. Point will be taken here. Now piston is pressed down, volume decreases, but if gas expand, its pressure decreases, and if gas is compressed, its pressure will increase. So gas is compressed, pressure will increase. Point will be taken here. Again, volume decreased, pressure increase. So this is first state, this is second state, and system is taken from this state to this state. And in this state, there is another example. This is piston containing gas, but here piston is locked. If piston is locked, initially there is some pressure and volume. Point is taken here. And if we are giving heat continuously, piston is locked, so volume will not increase, but piston is locked, then pressure will increase because energy is given continuously. Volume not increase, volume constant, pressure increase. Point is taken here. Again heat given, volume constant, pressure increase. Point here. So graph will be rise like this. Graph also indicates that in all three graphs we can decide where work is on the gas, where work is by the gas, and where there is no work. In this graph you see easily initial volume is this, final volume is this. Volume increases means work is done by the gas. In this graph, initial volume, final volume, final volume, volume decreases, so work is on the gas. And in this graph, initial volume, final volume, there is no change in volume. No change in volume means delta V value 0. Work done is P delta V, delta V 0, it means work done is also 0. So these are the indicator diagram. You can easily see that indicator diagram